Okay, let's go on. This is video 2. We've already covered all this. So let's go on to computer storage. Now, as I said earlier, computers store every bit of data in zeros and ones, on and off, or off and on, I should say. 0 is off, 1 is on. And think of it similar to a white light switch. And each 0 and 1 is known as a bit. It's a contraction for two words, binary digit. Binary digit, bit. So each 0 and 1 is known as a bit. A set of 8 bits is a byte. And as we saw there, when we had 8 bits set to 1, it was equal to 255 in decimal. And so it says, can we represent 256 different items? Yeah, 0 to 255, 0 being an item. So that's 256 different items. And that's enough to be able to store each capital letter, small letter, digit, punctuation mark in the English language or what's on your computer keyboard. We can use a byte to store any of the symbols on your computer keyboard. And just for fun, half a byte or 4 bits is a nibble, and that's the truth. Everybody thinks I'm kidding when I say that, but half a byte or 4 bits is a nibble. So a byte can represent everything on the keyboard, but how do we do that? Well, if you look in Appendix C, page 493 to 487, there's something called the American Standard Code for Information Interchange, or ASCII. And what it does is it has a binary and also decimal representation for each letter, character on your keyboard. So if you look in the book, let's see, C, capital C, that's on page 495. It's 01000011 in binary. Also says it's a decimal 67. That's a capital C. Now a small c is different. A small c would be, and that's on page 496, and that is a 01100011 or 99 in decimal. We can also, like I said, do any of the characters and a percent sign. I just have to find where percent sign is here. Okay, that's on page 493. There it is. And that's a 00100101 in binary or 37 decimal. So these are the binary representations in 8 bits, and also shows in hex, for anything in your keyboard. And one of the parts of your homework is write your first name in binary and decimal, and also says octal and hex, and we'll get that later. But my first name is Bob, capital B-O-B. And if we look at this, let's see, right here, let's get rid of that. And I'm trying to get rid of the, someday I'm going to learn how to get rid of the, okay, there we go. Capital B, if you look up, is 01000010 in decimal. Small o, 01101111 in decimal. I'm sorry, in binary. Small b, 01100010 in binary. Well, this is a capital B, this is an O, small o, and this is a small b. And it's equivalent to 66 decimal, 111 decimal, and 98 decimal. And like I said, on your homework, you'll be asked to put it in binary. Decimal, when it says characters, this is the characters right here. B is a character, O is a character, and B is a character. And just split each character out into its binary, decimal, and that's in the book, so it's just to look up. And I'll show you later on in other videos how to do it to hex and to octal. And can we sort the names? Yes, we can. Knowing that these are numbers, like here, let's look at, it's easier to do in here, 66. Well, I know 66, I might go in ascending order. So anything that starts with a C, capital C, would be 67, and that would come later. Anything with a capital D is 68, and that would come later. We could sort these based on the numbers. And of course, the computer would sort them based on the binary numbers. So that's how characters are stored within the computer. Now, we have 16 bits, and that can do every character in the English language. But there's also called a Unicode system, and that can represent 65,536 symbols. It's 60 bits. It's 2 bytes. And so it's enough for all the characters, numbers, and punctuation worldwide. And so a lot of times if you have kanji characters for Asian languages, it can accommodate that. And the first 256 characters of the Unicode system are exactly the same as the ASCII tables. So now, we talked about going from binary to decimal. Let's look at going from decimal to binary. Now, this is a little more complex. And so what we have to do is, first we have to subtract the decimal number, whatever decimal number we have, by the highest multiple of 2 possible. So we subtract the 2's multiple from the decimal number, and we record a 1 in that base 2's column. And I'll show you some examples of this. And then we continue with the next lowest multiple of 2. If it can be subtracted, we record a 1 in that base 2's column. And we keep going until we get to a 0. So let's just look at that here. So here we have the number 210. Okay, so, oops. I don't know why it keeps going to 0. So we have the number 210. Now, if I think about 210, I can start with 1, 2, 4, 8, 16, 32, 64, 128, 256. Okay, 128 is the highest number that's less than 210. 128 is 2 to the 7th. So that's 128. So I put a 1 in the 2 to the 7th column. Right there. That's the 1. Now, if I subtract 128 from 210, I get 82. Well, this is 128. I can do 2 to the 6. 2 to the 6 is 64. So I put a 1 in that column. And truthfully, it becomes a 1, 1. Since I had a 1 up here and a 1 here, that's the 64. Then I subtract 2, I get 18. Well, the next one after 64 is 32. If you just divide by 2, 128 divided by 2 is 64, divided by 2 is 32, which is 2 to the 5th. I can't subtract 32 from 18. So I'm going to put a 0 there. So that's this 0. Oh, I'm sorry. That's, well, this, just forget this. There's a 0 there. Now I'll do 16. Well, I can subtract 16 from 18, and that's 2 to the 4th. So this one was a 0 from above. And here's the 2 to the 4th. So I got 1, 1 from the first 2, 0 from the 2 to the 5th, 2 to the 4th is my 1. Subtracted, I get a 2. 8, 2 to the 3rd, which is 8, is too large for the 2, so that gets a 0. 4 is too large, because that's 2 squared, so that gets a 0. But 2 to the 1 works. 2 to the 1 is 0. And so here's my, let's see, right here is my 2 to the 7th, 2 to the 6th. 5 didn't work, so 0. 4 worked. 3 and 2 didn't work, that's why there's 0. 1 works. And really, I don't have to do the last one because I already got 0, so I just put a 0 at the end. And so there's the columns. And so the decimal number 210 is equal to binary 11010010 in decimal. So let's try converting the following numbers. 23. Whoops, 23. Well, we know, let's do 8 bits. 2 to the 7th, which is 128, is 0. 2 to the 6th, which is 64, is 0. 32 is 0. So the first one is 16. So I can subtract 16 from it, and I get 7. So I get 1 there. Okay, 8 is going to be 0. Can't subtract an 8 from 7. But I can do a 4. So I do a 4. And that's 3. So I can do a 2. That's 1. And I can do a 1. And that's 1. And that gives me 0. So this is 2 to the 0. 1, 2, 3, 4, 5, 6, 7. And again, 2 to the 7 is 128, which is too big. 64, 32, 16. So 16 was the first one I could use. And that's why I set the column in the 16th column. 8 was too big. 4 was good. 2 is good. And 1 is good. So 2310 comes out to be 0, 0, 0, 1, 0, 1, 1, 1 in binary. And notice I put it in 8 bits. It's much easier if you can keep everything into 8 bits and look at it that way. So let's look and see if we got that right. 0, 0, 0, 1, 0, 1, 1, 0. I'm sorry, 0, 1, 1, 1. So it is correct. So let's just erase all this. So let's do the next one. So we got 1, 1, 1, 1. And again, it's the same way. So we look at it. Get rid of that. Okay. So what we want to do is 1, 1, 1, 1. 128 is the 2 to the 7th. That's what I do here. 2 to the 7th is 1, 1, 1, 1, so that's no good. That's 128. 2 to the 6 is 64, so that's good. So we take 64, subtract it from 1, 1, 1, 1, and I get 7, and 6 from 10 is 4. I believe that's right, 47. 7, 4 is 1, and that looks good. Okay, so that's now 64. The next one's 32. So it's 2 to the 5th, which is 32. 2 times 2 times 2 times 2 times 2, which is 32. And I get 5, 15. Next one is just 2 to the 4th, which is 16. Well, I can't put 16 into 15, so that's 0. 2 to the 3rd, which is 8. That's good. Gives me 7. 2 to the squared, which is 4. That's good. Gives me 3. So I got 4 there. 2 to the 1, which is 2. That's good. So put a 1 there. And 2 to the 0 is 1. And that gives me 0. So I have 0, 1, 1, 0, 1, 1, 1, 1. Let's see if that's right. 0, 1, 1, 0, 1, 1, 1, 1. Okay, so we do have that correct. So erase all this. So hopefully you kind of seen the pattern of what's going on with going from decimal to binary. Okay, next one. 200 and decimal. Okay, again, 256 is, or 255 is the, 128, I'm sorry, is the highest, 2 to the 7th, 128. So, what we want to do is, 128 will work. Okay, so 2 to the 7th is 128. So we subtract 128 from here. We get 2. 2 from 9 is 72. So we put a 1 there. 2 to the 6 is 64. That will work. We get 8 left. So 64. 32 cannot go into 8, so that's a 0. 16 cannot go into 8, so that's a 0. 8 can go into 8, so that's a 1. And we have 0 left. So this is 2, let's see, this is 2 to the 6, 2 to the 5th, 2 to the 4th, 2 to the 3rd, which is 8. Since it's already 0, then I know 2 squared is 0. I know 2 to the 1st is 0, and I know 2 to the 0 is 0. So our number is 1100, 1000, and that's in base 2. 1100, 1000. Okay, so we got that correct. And again, if you want to stop the video and try it yourself before I show you the answer, you know, it's good practice. I think we have one more here. 243. Okay, again, I know 2 to the 7th is 128. So 2 to the 7th, 128. So put a 1 there. Subtract 128 from that. That's a 5. 2 from 3 is 1. And was that 115? 5 and 8 is 13. 1, 4. Yep, 115. Okay, so now I got 2 to the 6, which is equal to 64. So I can subtract 64 from there. 1 and 6 from 11 is 5, so it's 51. 2 to the 5th, which is 32. And that's good, so that's a 1. So let's put up here 51 minus 32. 2 from 11 is 9, 19. Okay. Then we have 2 to the 4th, which is 16. 16 is good. I can do it. Left over 3. Get rid of that. So now I got 2 to the 3rd, which is 8. So this is left over 3. 8's no good. I can't put 8 into 3. 2 squared, which is 4. 4 doesn't go into 3, so that's a 0. 2 to the 1, which is 2. I can do that. 3 minus 2 is 1. So that's good. And 2 to the 0, which is 1. I can do that. So 1 minus 1, which is 0. So I get as the answer 1111 0011. 1111 0011. Yep. Correct answer. So I'll erase this. So that's how we go from decimal to binary numbers. It's kind of the opposite. And then you can always check it if you wanted to. I could just say, okay, let's look at this one. I know this is 2 to the 0. 1 times 2 to the 0. That's 0. Looks like a 6. Plus 1 times 2 to the 1st. Plus 1 times 2 to the 2nd. Plus 0 times 2 to the 3rd. Plus 1 times 2 to the 4th. And if I look at that, 1 times 2 to the, let's see, 1, 2, 4, 8. 1 times 16, that's 2 to the 4th is 16. So 1 times 16 plus 0 plus 1 times 4 plus 1 times 2 plus 1 times 1, which is equal to 16 plus 4 plus 2 plus 1. So it's 23 if I add that up right. So I can go both ways just to check to make sure my conversions were correct. Whoops. So that kind of gives you a way to go back and forth to make sure you know that you're doing it right. Okay. So that's where I'm going to stop here. The next video we'll talk about adding and subtracting binary numbers.